So in this topic, you should suspend binomial expansion for now. In this topic, we will try to, from what I wrote here, we want to be able to split combined fraction into partial fractions. Now, what do we mean by partial fraction? The starter that you did, you got this, right? So this is the combined fraction. You started from this partial fractions. These are the partial fractions that are added together. Even minus can be said to be add. That's like adding a negative number, so it's still addition. These partial fractions are added together to form a single fraction. So the process of splitting it back is what we mean by resolving into partial fractions. That's the point in this topic. Why would this interest us? When you get to topics like integration and you encounter a problem like this, integrate maybe 3x plus 19 divided by x minus 2, x plus 3 dx. You have to be able to remember partial fraction, because if you have it in this form, it is easier to integrate. When we get to that, you will understand what I mean. Another way, another possibility is the question says, for example, expand in ascending powers of x up to maybe x cubed. This same thing, square root. If you are able to put it in this form, maybe not exactly, because we can't really say the square root of a negative. But my point is, if you are able to split it, there are so many things we can do in between. Of course, the square root case will not work this time around. Okay? There are so many things we can do. But first, how do we split a single fraction into some of its partial fractions? How do we even know that, oh, this has to be 2, this has to be 3, oh, this has to be 1, and it will work again if we try to put it back like it did in the starter activity. Now, this problem will be classified into 4 categories. We will deal with denominators with linear factors, like this one. These are linear factors. So when you look at the original question, you could say, oh, this is linear, this is linear, right? So we will have a way, we will deal with those cases first. After that, we'll deal with denominator with quadratic factors. So you have squared somewhere that cannot be factorized. Of course, when you have a question like 1 over x squared minus 9, now this is not quadratic factor problem. Because actually, this can be written as x plus 3, x minus 3, right? So it still becomes category A. Do you understand? We will deal with denominators with repeated factors. What do we mean by that? In this case. So because you have x minus 2 is a factor, then you have x minus 2 squared. It's also a factor, isn't it? That's what we mean by repeated factor. Then we'll deal with improper fraction. Improper fraction is when you have quadratic divided by linear. X squared over 9 divided by 2x plus 3. This is an improper fraction. Because the degree here is what? What's the degree of x here? And the degree here is? That's what makes it improper. So these are the 4 cases we will deal with. I will only introduce you to the first one, and in 5 minutes we'll wrap it up. Now, to solve partial fractions, can you check if we can see this part? To solve them, we'll look at these 2 methods. Because they do not all work in every situation. The first one, call it the cover-up method. That's the easiest method. But it's worked mostly for category 1. You can use it to solve from the beginning to the end of category 1 problems. But the moment you get to quadratic, it probably works once in one of the cases to get one of the variables. It doesn't work further. But the second method, which is expansion, I just say expansion method. It's not really like called that, so that's why I put it in quote. That is, it involves expansion and comparing coefficients. Okay, expansion and coefficients. So this will work in any case, but this is easy in the first case. Now, I'll quickly show you. You have done this to get this. Now let's see how we can put this back in this form. When we come tomorrow again, I'll take maybe one or two other examples and you practice the whole of tomorrow on this one. Okay, so you can also understand better. So let's see. The first category, denominators. So the A part now, denominators with linear. Mr. Cheng, can we get this part? Yeah, you set it. If we have 3x according to you, 19, divided by x minus 2, x plus 2, no, actually minus. I think I didn't get enough to x plus 3. And you want to split it back into 2. We know, because we have done this before, that there are 2 parts and there are numbers at the top. Those numbers are the unknown. If only we know those numbers, then everything is over, right? So those numbers will be denoted with letters A, B, C in that order. So the first one, I say, oh, this is actually going to be equivalent to x minus 2 plus some number over x plus 3. But this could later be minus if B happens to be a negative number. But by default, you write minus here. You write plus sign. Does it make sense? So we know that, oh, for you to get this, you must have added 2 partial fractions with a number divided by the first one, a number divided by the second one. That's what we do. I will only use the cover-up method today. When we come tomorrow, I will extend it further. From this point, you try to clear all the fractions by multiplying by the LCM. So in this case now, we're going to multiply by, what is the LCM of all the denominators? Quickly, everybody.
1.
I don't know where that 1 came from. I'm trying to imagine where. Yes, quickly, please. I don't know where you got that from. Anyway, let's move on. So you're going to multiply, because I want to clear the fraction. I want it to just look like an equation. Linear, quadratic, cubic, nobody cares. So if I multiply this on the left, what do I get? 3x plus 19, and that is equivalent to, if I multiply by this part, what do I get? A, x plus 3, and if I multiply by the second part, b, x minus 2. So now this is how the cover-up method works. In the cover-up method, we want to remove one and get the other one, like elimination. The cover-up method is like elimination. If I can eliminate A, I can get B. If I can eliminate B, I can get A. Do you understand that? Now to eliminate A, all I need to do is to make sure that this bracket is 0. If this bracket is 0, A times 0 is 0, then that term is gone. Do you agree?
Yes.
So what can I do to make this bracket 0?
X plus 3 equals 0.
How can your plus 3 be 0, Leo?
Oh.
Alright, so again, what do we do to make this bracket 0? X must be minus 3. So what you do is to say, put x as negative 3. Alright? Now if you put x as negative 3, the first part is 3, negative 3, plus 19. I need all attention, please. I can see some of you are distracted. The second part is, this is minus 3 plus 3. I don't know what Colista is doing there, doing something else while we are doing something here. Do you mind sharing what you are doing with the class? Alright, so B will be minus 3, minus 3. The instruction says put x as minus 2. So the instruction says put x as negative 3. So everywhere we see x, we put negative 3. Every other thing remains constant. And if you notice, this will become 0 and this is gone. Right? So this is going to be 0, definitely. Yes? And if that happens, this is what? Minus 9 plus 19.
No?
Am I wrong, Leo?
Yes, it's negative 9 plus 19.
Can I at least finish what I'm writing? And this is what? Negative 5. So the equation is now reduced to 10 equals minus 5b. And b is equal to what? Negative 2. So similarly, if I put, Mr. Chang, can you help please again? Similarly, if I put x as, so now, I've just eliminated a to get b. So I do the same. I try to eliminate b to get a. If I eliminate b, what do I need to do to make sure b is gone? 2. I put 2, x as 2. If I put 2, then everything here again becomes 3, 2, 19, a, 2 plus 3, right? B, 2 minus 2. And again, this is gone, right? So this becomes 6 plus 19, a, 5. So I have here 25 equals 5a, which means my a must be 5. Then you go back to the beginning. This is your beginning. So it means, therefore, the original fraction, 3x plus 19, x minus 2, x plus 3, must have been as a result of 5 over x minus 2. And because b is negative, minus 2 over x plus 3, which is the starter that you combine it first. We'll discuss this further when we come to class.
Okay.
Alright? So let's go home and eat some dinner and be lazy and do whatever.
Bye.